going to explore 1A5 piecewise functions. Every now and then you're going to hear me say piecemeal. I don't know why I do that reflexively or without thought. Just ignore that. I'm probably going back to my history days. Alrighty, so we're going to look at three basic types. There are other types your calculus teacher will explore, and we'll probably jump into some of these as well, these other types. But we have the infinite discontinuity, which is illustrated right here. And as x approaches c from the left or from the right, we have y basically increasing or decreasing infinitely. Then we have the jump discontinuity, which if we approach from the left or approach from the right in this direction, c is actually two different values. And of course our third one is going to be where c is going to be the same value as I approach from the left or from the right. Again, these are three basic ones. We can put some of these together, and your calculus teacher will explore other examples. So we're going to keep it fairly basic. So when we write these, I'll give you a graph, or I'll give you the functions in here and have you graph them. So let's take a look. And right down here I wrote a technique. These are steps. They're not necessarily a mathematical law. It's just something to keep in mind. Labeling points. Well, here we can. I mean, I don't know why we would go through all the trouble, because it's pretty self-evident. -1, -1, 0, 0, so on. But we're going to have more complex ones later on. And what we're going to do is, first of all, we just want to write the functions. So we want to write the function for this one, and we want to write the function for this one. Well, this looks like the parent function of y is equal to x, and that's exactly what it is. We can see our slope going up 1 and over 1, so we have 1 and 1. So this is just going to be y is equal to x. Now we don't write y is equal to x, because here's my y equal to already. We're just going to put x, and we're going to write an if statement if x is, since this is a enclosure, I could write this as a inequality or as interval notation if x is greater than -1 and equal to or less than 0. Then, of course, we're going to come up to here and continue on. This is y is equal to 1, the line y is equal to 1. And I could write 1 if we're going to go from 0 and then none inclusive, so x, and then less than or equal to 2. And that's pretty much it. I could have wrote this as interval notation of 0 to like that, and the same for up here. I could easily have done -1, 0 with it inclusive. All right, so this is what it would look like. I could have done this to make it more clear if someone felt a little uncomfortable writing it like this. I could have done x plus 0 for this one, and I could have done 0x plus 1. They don't like that 1 sitting there. So there's different ways to write it. So here I have a piecewise function where I have three parts to it. And what I want to do is start graphing these things. Well, there's a couple ways to do this. I can do a t-chart, which is sometimes very recommended. I'm going to do a t-chart for the first one. We'll call this purple. And this really is just the parent function of the quadratic shifted left by 1. So if you have your parent functions down, this actually is a pretty darn easy exercise. But let's go ahead and do a quick t-chart. I'm going to do -1, -2, and -3. Because guess what? We're less than 1. So I'm just going to have 0, 1, and 4 as my outputs, my y's. And I can graph this. So I would have at -1, 0, okay? And that's going to be an open circle. And it's just going to go up in our quadratic way, -2, 1, okay? -3 way over here, and 4 way up there. So it's going to go up like this. And of course I'm going to botch it a little bit because I'm on my writing pen here. So let's take a look at this one. Let's make this one green. Yes. So I can do, it's supposed to be green. Why isn't it not green? There we go. X and Y. And this is the quadratic shifted right 2. I mean shifted down 2. So our vertex is going to be right down here. And it's equal to, so I'm going to go ahead and put my dot right here. And let's go ahead and graph this. We'll do -1, 0, 1, and 2. negative 1, 0, 1, and 2. Output's going to be negative 1, negative 2, and negative 1 and 2. So I already graphed my vertex. So let's go ahead and do the negative 1, and that's going to be inclusive. See that right there? So it's going to be a solid dot. I'm going to reflect that over. So I got 1, negative 1, and I got 2, 2. And that is going to be a solid dot as well. So I have this. And I'm really trying hard on my writing pad. There we go. Third one is we have our square root. And if we look at our parent function, all this is just shifted over right too. So let's go ahead and do this one in blue. X and Y. And I'll do 2, 3, 4, and 5. 2, 3, 4, and that'll give us a pretty good picture. Well, 2, that's just going to be 0, so that's easy. 3, that's going to just be 1. 4, that's square root of 2, which is about 1.4-ish. Okay. And when I put in 5, then that's going to be square root of 3. That's going to be about 1.7-ish or so. Okay, I could put that in the calculator and get more precise, but shoot, my little dot here covers a bunch of points already. So let's go ahead and graph that. Now looky here, we are not inclusive right here. So it's going to be an open circle, okay? And we're going to go to 3, 1, 4, 1 point something, and it's just going to go like this, okay? It's going to go up and over. And there you have it, okay? So we just graphed these things. Now, sometimes I'm just going to give you this and say evaluate f to negative 3. So you come up here and say, okay, where does f negative 3 falls in? It falls in right here. So you just do f of negative 3 is equal to negative 3 plus 1 squared, which is equal to 4. We already evaluated it right here, by the way. Okay, so that's it. I'll get this loaded and get the next lesson going.